Welcome to Roof Time! In association with Moose Roofing out of Omaha, Nebraska, I am your host, Austin Anderson. I major in roofing and minor in chainsaws, mini bobcats, three-wheelers. In today's video, we will be talking about how to destroy the dreaded ice dams of the Arctic months. If you haven't yet, please hit subscribe, ring the little bell, and be notified when we release a new video. So, if you live in an area where snowfall pours from the heavens and cold temperatures pucker your delicate little lips, that means ice dams are coming. Literal barriers of ice that form upon your roof, which prevent snowmelt from running off your roof back into the soil where it belongs. Ice dams prevent the circle of water. You see, winter concocts a unique attic ventilation problem in areas where the snow falls and cold temperatures dominate the short-lived sunlit days. Ice dams can form when these conditions exist. Warm air accumulates near the peak of the attic. This is much more common than you could ever imagine. Most attics experience some heat loss from attic insulation. And because warm air rises, like so, the upper portion of the attic is always the warmest. Usually that pocket of warm air won't result in problems, that is, until the following dreaded conditions align like the planets. Lower areas of the roof remain cold. This is a common condition, especially in the area just above the eave where temperatures may not be much higher than the ambient outdoor air. If the outdoor temperature is well below freezing, this concocts the perfect condition for an ice dam formation. A heavy snow cover accumulates on the roof. The snow accumulation provides the necessary moisture and acts as a layer of insulation, preventing heat loss through the roof sheeting. Temperatures in the attic are typically warmer than they are on days when the roof is free of snow. Can you believe that? You better. When all three conditions align like the planets, ice dams form quickly. Trust me, they do. The heat in the attic causes snow to melt near the roof's peak. The water from the melting snow flows toward the eave area where the colder roof temperatures allow it to refreeze. If this happens over several days, melt, freeze, melt, freeze, melt, freeze, the refreezing of snow melt can form an ice dam. The weight of the dam of ice can damage gutters, fascia. When it eventually falls, it also can damage structures or the shrubbery below. Yes, your wife's plants or yours. But the most significant damage of all occurs when the water pooling inside the dam begins to infiltrate under shingles. The shingles get damaged and possibly destroyed. A much more severe thing can transpire. Insulation can be soaked. I know what you're saying. Oh, the humanity. Reducing its effectiveness. Plus, water can infiltrate into both exterior and interior wall cavities, leading to structural damage and the destruction of painted surfaces. The paint is in jeopardy, folks. At the very least, mold and mildew can form, creating unpleasant odors and mold spores, resulting in poor indoor air quality. Not to freak you out, but one time a guy inhaled mold from bread and it ate his whole face off. His whole face. Crazy story. Anyways, when the homeowners set out to eliminate ice dams, their typical response is to add more insulation to attics. But even if you stuff the whole attic to the brim with insulation and pack it in there, it will not eliminate the formation of ice dams. Because an effective attic ventilation system must be part of any solution. A properly designed ventilation system creates a cold roof. What is a cold roof, you ask? I'm glad you asked. A cold roof is a condition where the roof temperature is equalized from top to bottom. We call this Denzel Washington. A balanced roof temperature, in turn, helps eliminate the conditions that lead to the formation of ice dams. Proper ventilation allows a flow of air to sweep along the underside of sheeting, minimizing temperature differences. Ventilation alone is not a complete solution either. For maximum comfort, reduced structural damage, and optimal energy conservation, ventilation must be used with an ice and water shield underlayment in addition to insulation. Ample insulation is required to minimize heat losses, and high-efficiency air movement is necessary to remove any heat that enters the attic. To reduce the possibility of these damn ice dams, one must use a 3-step approach. 1. Install adequate attic ventilation. Because ice dams form when a roof has warm upper surfaces and cold lower surfaces, the solution is to equalize, Denzel Washington style, temperatures over the entire roof. The most effective way to equalize temperatures is to create a cold roof. To do that, you need a well-designed attic ventilation system that will supply airflow along the entire underside of the roof deck. That's critical, because only a uniformly distributed airflow can reduce variations in roof temperatures from peak to eave. Peak to eave. One of the most efficient and effective systems from both a cost and performance standpoint uses ridge vents and an evenly distributed layout of intake vents under the eave. These are called the soffits. 2. Install adequate attic insulation. Attic insulation serves 2 purposes. First, it reduces heat loss from a home's living quarters. Since heat loss is a crucial factor contributing to ice dams, stopping it at its source is critical. Second, so we're at 2 of 2. Adequate attic insulation diminishes the energy impact of having cold air flowing through the attic. When installing insulation or checking existing insulation, be sure to install adequate amounts around electrical fixtures and wiring and plumbing chases. These areas often contribute to significant heat loss. With existing insulation, check for water damage and areas compressed by foot traffic or stored objects. Finally, make sure existing insulation meets today's R-value requirements. 3. If possible, install an ice water shield underlayment. Even the most effective attic ventilation system may not be enough to eliminate ice dams. A combination of weather conditions, roof pitch, building orientation, and other factors may allow ice dams to form under certain conditions. If that happens, an ice and water shield underlayment barrier can minimize and possibly eliminate water infiltration into the building structure. Install an ice and water shield underlayment according to the manufacturer's instructions. In general, install an ice and water shield underlayment at least 2 feet above the interior wall line. Many contractors say a 3-foot barrier is even better, because if you're going to go 2, why not go 3? You know what I'm saying? When working in valleys, install an ice and water shield underlayment 3 feet on each side of the valley's center. In order to stop ice dams, this is what is needed. Although it may seem like a considerable undertaking, your attic space must be adequately ventilated so your home can live a long and prosperous life. Please comment below with any questions you have, and we will respond to them as quickly as we can. Make sure you subscribe and ring the little bell so you're notified when we release a new video. With that being said, until next time, shine on, you crazy diamonds.